welcome. Today's lecture number 9, let us discuss about the mechanisms of climate change. Friends, we have understood what gives us the climate that we have these days, and then in today, and that means the 9th and 10th lecture, let us discuss about the mechanism. So, we will talk about the natural and also the anthropogenic attributes that broadly explains the mechanisms of climate change. So, these are the concepts we are going to cover. The first is mechanisms of climate change, natural processes that are included here, particularly in today's 9th lecture. And then we will also see how we have got the information about this, how sure we are about this to say that these are the mechanisms that explains the climate change. So, we will try to understand what are the records to study the climate or the change in the climate. So, what are the records available with us to understand in terms of the climate change. And more importantly, let us also discuss about this C14 and O18 proxies, the two isotopes, because the usual valence is what do you say, atomic number goes C12 and O16. So, we have 14 and 18. So, these two how they serve as proxies, we will try to discuss in this course of getting information on climate records. The fourth one is orbital forcing. In today's lecture number 9, we will try to understand that because of Earth rotation, revolution, tilt and obliquing, so how we are getting the means how the variation in the past climate, dominantly with respect to taking temperature as the proxy or the variable or the indicator, we will try to understand how this orbital forcing theory, as far as the Earth rotation revolution around the sun is concerned, explains them. And we will also see how after corroborating these eccentricity, precision and obliquity, in a sense the path, the orbit it takes, the orbit Earth takes around the sun, the tilt and the oblique. So, which we are going to discuss in terms of eccentricity, precision and obliquity, how together they explain the orbital theory of glaciation, and in that in the course of or in a curve that explains the insolation and given by the geophysicist the great Milankovićh. And this particular graph gives us the basic idea that how Earth's average surface temperature, or I would say how Earth's average temperature has fluctuated in past 500 million years. So, we all know Earth, we have already discussed in some of our past slides, and we know that Earth is the solar system including Earth is somewhere originated before 4.56 billion years. So, the moment we say billion, so 1000 million is 1 billion, 10 lakh is 1 million and 1000 million is 1 billion. So, here in the x axis, if we go from right to left, that means from present to past 500 years, we have plotted in terms of the average temperature of Earth. So, it can very well be seen on the y axis, the bar goes between 10 to 30 degree centigrade as far as the Earth's average surface temperature is concerned. And in that, if we mark on the upper side of the x axis the 505 Cambrian era, then all these geological eras have been mentioned here, and it clearly says or indicates that the Earth's average temperature has fluctuated between 10 to 30 degree more than 4 times, and look at the fluctuation pattern, it varied between 10 to 30 degrees. So, history may be repeated, from these evidences it says that history is always repeated. So, you see it here, the lowering of this curve indicates some ice age or cool phases or cool ages, whereas at the upper end it indicates some warm era or what you say, the interglacial periods. So, this is a very important curve that talks about the global temperature during past 500 million years, and this has been taken from the book given by Hanna 2021. And we will continue our discussion in terms of the process, particularly what are the natural processes that dominantly explains the various mechanisms that contribute to climate change explanations. So, first is the geometry of Earth's orbit. We are going to discuss it more in today's this lecture number 9. And then the second one is plate tectonics. Third is the Earth atmosphere, particularly with respect to the greenhouse gas composition and its variation or fluctuation in current day. And the fourth one is in terms of the changes in the runoff pattern that leads to an alteration of thermohaline circulation more in the oceanic phase. And the fifth one is in terms of the solar variability. We know about the sunspot. The sunspots are the dark spots which takes a cycle of 11 years to rotate or repeat. So, all these sunspots or the dark spots are always surrounded by white spots called faculae. So, this the solar variability explains to certain fluctuation in terms of the Earth's average temperature. And the sixth one is the aerosols. It alters the radiative balance. It also alters the reflectivity property of Earth. So, these are the 6 different mechanisms that dominantly or cumulatively explains the mechanisms of climate change. So, let us focus on the geometry of Earth's orbit in today's lecture number 9. This curve here, we have plotted 3 curves there. So, on x axis this indicates the temperature variation which has been plotted from 3 proxies. So, proxy number 1, little upside, that is the blue color. You can see on the y axis it is the O18 isotope proxies have been plotted. Everywhere on x axis it is 80,000 years before present to present. So, if you move from right to left, that means we are going backward from present to past 80,000 years, and you can very well see in the middle one, which is depicted in the green color, has again came from O18 proxy in terms of per millimeter or miles, and then you see it here in terms of the curve which is closer to or between 0 to 10,000 years. All of them are shooting off. The third one talks about or reflects the percentage of reflectance in terms of 550 or reflectance at 550 nanometer. Okay, so, we all know the VGR, violet, the visible range, VGR person. So, at 550, so 550 just the start of the red portion. So, red part of the electromagnetic means so it starts, it goes somewhere from, it starts somewhere from 550, 555 and goes up to 760. So, if you see it here from this reflectance or percentage of reflectance, the sediment color has been picked from marine productivity studies taken from Venezuela, and this also says that there is the what you say, the percentage of reflectance is relatively less because it is plotted from 9 to 23% and the percent of reflectance is little less towards the present day. So, all this actually in turn explain or indicates the temperature variation. So, what is this O18 temperature proxy? As has been mentioned on the right hand side, the O18 is relatively heavier than O16. So, it evaporates comparatively at a lesser rate, in turn takes more time. So, this ratio of O18, that means O18 upon O16, that is why can be used or is being used by the geologist to understand the temperature proxy. So, what does it mean? Low O18, that means it indicates cold era or ice age, and low O18 in marine, it talks means in the ice it talks about cold era, and in the marine it talks about the or it indicates the warm era. Similarly, with respect to C14 dating proxy, so found by the cosmic rays, there we talk about the half life period. So, half life period is 5730 years, that means less than 1% of the organism's carbon is having this C14 element in that, because the regular one is C12. So, that means this C14 you can measure because it decays very slowly even after the death, because the C12 accumulation stops when an organism, including plant, it dies. So, less C14 means older age and vice versa. So, that is how C14 and O18 they behave. So, O18 gives us information as temperature proxy. C14 again gives us information as far as the date or the time is concerned. So, corroborating all these clues, all these indications, we come out with information on or about the temperature variation in past, linking it to the climate or climate change. So, how means with respect to the time, what are the different ways we collect the records in terms of climate records. So, longer time frame, we go for continental and coastal sediments or oceanic sediments. Relatively, we have started using the proxies as far from the lake sediments and coral reefs or ice cores. And as I just mentioned, the tree ring information gives us dating proxies, some historical information here and there which has been captured, which has been recorded by people of the previous era, previous centuries or decades, that also use which we put under the historical framework. And then we are in the era of instruments. Since past several decades, we have put several instruments. So, we are taking observation, we have erected different measurement systems. There is a satellite based observation system based on civilian satellites are concerned. It goes more than 50 to 53 years. So, we are now loaded with lot of information about the climate and the climate change. So, ice cores, intermediate resolution and time span, including coral reefs, sediments, lower resolution in a kind of million years time span, tree rings in terms of annual few thousand years at best, and the high resolution instrumentation are since last or past several decades. So, this is a kind of time span as far as the records are concerned from these different measurement protocols from methodological point of view. Now, friends, let us move ahead when we try to reconstruct the climate history using the information taken from the ice core from Antarctica. So, the CO2, the carbon dioxide, methane and temperature variation have been correlated, corroborated. If you can see on the upper three, the top one represents the temperature variation between means since past 800 800,000 years before present. The present is on the left hand side and the 800,000 years before present is on the right hand side, and look at the variation pattern. And I would like you to focus on the upper three, and the correlation pattern means broadly you can very well see that the methane pattern of variation and the carbon dioxide are also corroborated with respect to the temperature variation. So, what does it mean? If there is a rise in, look at the present, the immediate past 50-60 years, 20-30 years, extreme left only, which is shown in terms of a dotted line. Everywhere it is the methane percentage have shoot up, the carbon dioxide percent have shoot up, and in turn the temperature has risen. So, a important corroboration that rise in these greenhouse gases has perhaps led to rise in the temperature of the present day or since past few decades, which is the first revelation where scientists have given to the world that the greenhouse gases are the dominant contributor of temperature rise as far as the present day is concerned. Now, let us go back in terms of understanding the orbital forcing on climate change. This gentleman, James Croll, in 19th century, he is a Scottish scientist. He first, it is his idea, it is his brainchild, it is his proposition for the first time to the world that there could be the orbital variations and the variation in the snow albedo. So, he first time thought and provided this information to explain the orbital forcing contribution to climate change. He said that perhaps the variation of the orbit, that means the earth rotation, revolution, tilt, all these things actually contributing, and also the snow albedo, the reflectivity property of snow, these are probably contributing or can explain the climate change. So, the feedback explains or predict the ice age. So, what he proposed? Higher eccentricity. I am in our next slide I will explain you what is eccentricity. This is, see, earth takes an orbit around the sun, and it is not a circle, it is elliptical. So, this elliptical orbit, okay, what is its eccentricity, represented by the signal or the symbol E. We talk or we discuss in terms of high eccentricity gives us the colder winter. High eccentricity also explains the ice ages probably at 22,000 years epochs or intervals. So, ice ages alternate between hemispheres. Each ice age lasts about 10,000 years. This has been reported by Edwards in his publication 2022, and this is a very important clue, indication the Scottish scientist James Croll has given in 19th century. Now, taking this forward by this gentleman, the great Milankovićh, he expanded it. Mathematically, he calculated the timing of orbital changes. So, what he explained, the effects on climate due to eccentricity, precision and obliquity. He also analyzed the influence across different latitude, that is actually have a lot of calculation has gone back in terms of the calculation at every variation of latitude in terms of degrees, and that influence he has analyzed and put it together. And then also the support came from the deep sea sediments in 1970 when, and that sediment based analysis or the lab analysis have supported this Milankovićh theory. So, let us first understand what these three types of variations in terms of the Earth's orbit. So, in terms of the orbital changes, the first one is changes in the shape of the Earth orbit around the Sun, which takes which is explained by the term eccentricity. As you can see on the lower left figure, the sun and little bit of the what you say, the red color orbit, okay, which varies, it is not it does not take a constant what you say orbit, this varies. So, this variation in terms of the eccentricity, this variation is explained in terms of eccentricity, which takes an epoch of 1 lakh years and a broader epoch of 4 lakh years. And the second one is explained by the upper right figure called the obliquity. So, in terms of the obliquity, we discuss it in terms of the changes in the tilt of the earth axis. Friends, all of us know that it is 22.5, but it varies between 22.1 to 24.5 at an epoch of 41,000 years. Then the second one, which I will take later, is the oblong. So, oblong is coming because of the earth rotation. We all have played oblong during our childhood days. So, earth's oblong, actually you can see the what you say middle lower figure that talks about the oblong. So, because of the oblong, which is explained by the term precession. So, this precession the precession takes a cycle of 22,000 years. So, oblong of the earth's axis of rotation between 22.1 to 24.5 is repeated at an epoch of 22,000 years. So, 1 lakh year, broader one is 4 lakh years. 22,000 years, it varies in various literature, 20 to 22,000, and then 40 to 41, sometime in some literature it is referred to 43. So, 40 to 41,000 years in terms of the obliquity. So, now let us understand in terms of these diagrams the term eccentricity in more detail. So, eccentricity, small radiation effect less than 1% if it is, and look at this diagram here, and there we can see the variation of eccentricity at a 1 lakh year in a shorter time of epochs, and so at 1 lakh year this eccentricity varies. So, what is the take home, or what is the impact then with respect to this variation as far as the eccentricity or Earth's orbit around the sun is concerned? Small eccentricity leads to 7% summer winter energy difference. If it is large eccentricity, that means it is taking a larger what you say, the elliptical path, that means the energy difference between the summer and winter can go as much as up to 20%. So, within a year you will have a variation in terms of summer winter energy difference up to 20%. So, this is the important point taken from here in terms of the insolation. So, small eccentricity up to 7%, large eccentricity up to 20% energy difference. Now, in terms of the precession, so the oblong, okay, the oblong gives us the what is a precession, which are explained by the precession of equinoxes. All of us know these two terms, the solar and winter solstice and the vernal and autumnal equinoxes. So, equinoxes where the day and night length are same, 12 hours. The summer solstice where it is higher, that means the 21st June, and the winter is 22nd December, where you have a very longer night and the longest night and shortest day. So, friends, it is not fixed, it also takes a cycle of 22,000 years, and if we see here in terms of the position of Earth around the orbit, then it is very clear with respect to the date March 21, 22, the winter solstice December 21, 22, autumn 22, 23, and the summer that is June 21 to 22. So, accordingly you can see it here, if it is at 22,000 years and here it was just after 5,500 years the position, and the position here after another 11,000 years. Now you can see along this diagonal it is 11,000 and it is 22,000, just the opposite as far as this. So this can be very well realized in different hemispheres, southern and northern. And if we go back as a reference 16,500 years, this was the scenario. So this precision of equinoxes which happens because of the axial obel is explained by the term precision, and it also links to insolation. And then the axial tilt, as we know in terms of this 22.1 and 24.5 degree tilt of the Earth's orbit across its axis or at its axis, this cycle varies at an epoch of 41,000 years, and it controls the solar radiation distribution. So that means when low tilt, that means 22.1, less sunlight, so cooler summers and warmer winters. Whereas if the tilt is high, that means more sunlight and we have stronger seasons, that means relatively strong winter and strong summer. So hypothetical tilt, poles receive minimal radiation of if it is 0 degree, which is hypothetical, but the present tilt is 23.5, the poles receive moderate radiation, and it, as in this figure we are discussing, it varies between 22.1 to 24.5 at an epoch of 41 years repetitivity. So now we put them together to search for an orbital signal as far as the climate change is concerned. Look at this on the left side, we have put it in terms of the eccentricity modulation that varies between 0.04 to minus 0.04, and you have 4, 1, 3 thousand years, that means as I just mentioned the broader epochs of 4 lakh year plus. So it's approximate, and 1,000 years down below we can see here also, and the smaller side 23,000. And on the right hand side, when we corroborate them, 2 at a time, 3 at a individual at a time on the upper part, 1,41,000 and 23,000, and when we put 2 of them together and all 3 together, so upper 2 you can see 1,23,000, and the middle one 41 and 23, how is the pattern in terms of the signal amplitude, and in the right lower curve you can see when all these 3 figures, all these 3 curves have taken together, how the signal amplitude behaves. And now this is the combination of the cycles put together. So when Milankovićh put this in terms of his insolation curve, he found in terms of the, we have put 2 figures here, the sunlight insolation variation and down one ice ages in terms of the glacial periods. And if you can look at this in terms of the insolation on the upper one and lower one in terms of the ice ages, this explains the variation what I have told you in the third slide, that means the variation in the average temperature of the earth or the average global temperature. So the cyclic solar radiation variations is explained by causes of ice ages. The minimum means glacial period, and it confirms the link which is coming from the orbital cycles, and thereby explains the one of the important mechanisms of the climate change. So these are the references which has been used to understand or discuss about this particular mechanisms of or orbital theory as far as the orbital insolation theory as far as climate change is concerned, given by Milankovićh. And then the conclusion. In conclusion, let me summarize that these are the 5 points we discussed elaborately. One is natural climate drivers include plate tectonics, orbital geometry, greenhouse gases, solar variability, aerosols and run-up changes that together run-up changes which alter the thermohaline circulation. these together explains the mechanism of climate change. The C14 and C14 and O18, okay, they are these are the isotopes. The originals are C12 and O16. So, these C14 and O18 isotopic proxies, they reveal the temperature and the age variation through carbon through radiocarbon and isotopic analysis. The climate records differ in resolution. So, as I mentioned, in terms of spatial and the temporal resolution, when you go back to million of years, then we go for the sediment kind of things. When we are going for shorter one, we go for annual rings or instrumentation based, and this is with respect to time. With respect to space also, the instrumentation based or various satellites orbiting across the around the earth gives us lot of information these days, which are as recent as few decades from present. So, the fourth one, orbital forcing by eccentricity, precision and obliquity controls insolation, influencing the glacial and interglacial cycles, and Milankovićh theory mathematically links orbital changes to solar radiation shifting causing periodic ice ages. So, friends, with this 9th lecture today, we discussed about in detail about the orbital insolation theory given by Milankovićh. Thank you very much.